Have you ever looked up at the night sky, at all those countless stars and wondered, are we alone? It's a question that has captivated humanity for centuries. The universe is vast, almost incomprehensibly so. Our own galaxy, the Milky Way, contains hundreds of billions of stars. And there are hundreds of billions of galaxies out there. The numbers are just staggering. With so many stars, surely there must be other planets, right? And on some of those planets, life must have emerged. And on some of those planets, that life must have evolved to become intelligent just like us. Maybe even more intelligent. It seems like a statistical certainty. There should be alien civilizations everywhere. But then, where is everybody? This is the heart of a famous and unsettling question known as the Fermi Paradox. It's named after the brilliant physicist Enrico Fermi, who, during a casual lunch conversation back in 1950, supposedly asked this very simple yet profound question. If the odds suggest the galaxy should be teeming with life, why haven't we seen any sign of it? No radio signals, no giant alien megastructures, no spaceships zipping past Earth. Just silence. It's a genuine paradox because the two sides of the argument both seem completely logical. On one hand, the sheer scale of the universe makes alien life seem inevitable. On the other hand, our complete lack of evidence suggests we're totally alone. So, what's the answer? Today, we're going to dive deep into the most fascinating and sometimes terrifying possible solutions to the Fermi Paradox. Let's start with the argument for alien life, which is often framed by something called the Drake equation. Don't worry, we won't get bogged down in math. Think of it more like a recipe for finding aliens. It multiplies a bunch of probabilities together: the rate of star formation, the fraction of those stars with planets, the number of those planets that could support life, the fraction where life actually arises, the fraction that develops intelligence, the fraction that creates detectable technology, and finally, how long those civilizations last. When you plug in even conservative estimates, the Drake equation often spits out a huge number of potential civilizations in our galaxy alone. We're talking thousands, maybe even millions. So, if they exist, why can't we find them? This brings us to our first category of solutions. The idea that they exist, but we just haven't found them yet for some reason. One simple explanation is that space is just really, really big. Imagine you're trying to find a specific ant on the entire surface of the Earth. It's not that the ant doesn't exist, it's just that the search area is enormous and you don't know where to look. We've only been actively listening for alien signals with radio telescopes for about 60 years. That's a tiny blip in cosmic time. Maybe their signals haven't reached us yet, or maybe we just haven't pointed our telescopes in the right direction at the right time. Another possibility is that we're looking for the wrong thing. We're scanning for radio waves because that's the technology we understand. What if advanced civilizations use something far more sophisticated like neutrino signals, or gravitational waves, or some form of communication we can't even imagine? It would be like trying to listen to a Wi-Fi signal with a walkie-talkie. We're simply not on the right frequency. Or maybe they're intentionally staying quiet. This is the zoo hypothesis. Imagine a highly advanced civilization discovering a planet with emerging primitive life. That's us. They might decide to observe us from a distance, like we observe animals in a nature preserve. They could have a strict prime directive, a rule not to interfere with our natural development. We could be part of a galactic zoo or a protected sanctuary, completely unaware of our cosmic zookeepers. A slightly more unsettling version of this is that they are out there, and they're dangerous. The dark forest theory, popularized by the sci-fi author Cixin Liu, suggests that the universe is like a dark forest full of silent hunters. In this forest, every civilization is a potential threat. The safest survival strategy is to stay hidden and eliminate any other life you find before it eliminates you. Announcing your existence by sending out signals would be like shouting in the dark forest, "Here I am," a very, very bad idea. In this scenario, the silence we hear isn't because no one is out there, it's because everyone is wisely holding their breath. The only dumb ones are us, beaming signals out into the void. Now let's move on to the second major category of solutions. The idea that intelligent, spacefaring civilizations are extremely rare, or maybe don't exist at all, besides us. This is known as the rare Earth hypothesis. This argument suggests that the chain of events that led to intelligent life on Earth was a series of incredibly lucky flukes. It's not just about being in the habitable zone where liquid water can exist. You need a stable star of the right size, a large moon like ours to stabilize the planet's axis, a magnetic field to shield from solar radiation, plate tectonics to regulate the climate and recycle nutrients. The list goes on and on. Then, even if you get life, the jump from simple single-celled organisms to complex intelligent beings might be an almost impossible hurdle. It took nearly 4 billion years on Earth for that to happen. Perhaps that jump is the Great Filter. The concept of the Great Filter is one of the most compelling and chilling ideas related to the Fermi Paradox. It proposes that there's some barrier, some incredibly difficult step in the evolution of life that is almost impossible to overcome. The big question is, where is this filter in our timeline? There are 3 possibilities. 1. The Great Filter is behind us. Maybe the jump from non-living chemicals to the first simple life form was the incredibly rare event. Or perhaps the leap from simple prokaryotic cells to complex eukaryotic cells was the filter. If that's the case, we're one of the lucky few, or maybe the only ones to have made it through. We won the cosmic lottery, and the universe is our oyster. This is the most optimistic scenario. 2. The Great Filter is us, right now. This suggests that we are the first and only intelligent species to ever arise. It puts a tremendous weight of responsibility on our shoulders. If we are the only flicker of consciousness in the galaxy or even the universe, then we have a duty to survive, to explore, and to carry that flame of consciousness out to the stars. But there's a third, much darker possibility. The Great Filter is ahead of us. This would mean that many civilizations have reached our level of technological development before, but something inevitably happens that prevents them from going further. Maybe it's a self-inflicted catastrophe, like nuclear war, runaway climate change, or an out-of-control artificial intelligence. Or maybe it's a natural event like a gamma-ray burst that sterilizes entire sections of the galaxy. If the Great Filter is in our future, it means that civilizations tend to destroy themselves before they can become interstellar. The silence of the cosmos isn't because no one else made it this far. It's because no one ever makes it past this point. This is, by far, the most terrifying solution to the Fermi Paradox, because it implies we are heading towards a predictable and unavoidable doom. So, where does that leave us? Looking up at a silent sky, armed with a paradox and a collection of theories ranging from the hopeful to the horrifying. Are we alone? Are we being watched? Or are we just a fleeting moment of life, soon to be extinguished like all the others before us? The truth is, we don't know. And that's what makes the Fermi Paradox so powerful. It's not just a puzzle about aliens. It's a mirror that reflects our own hopes, fears, and our place in the universe. It forces us to confront the biggest questions we can ask. What is the meaning of our existence? What is our future? And are we capable of surviving ourselves? The search continues. Every new exoplanet we discover, every signal we send, every step we take towards becoming a multi-planetary species is a step towards solving this grand cosmic mystery. Whatever the answer is, finding it will change humanity forever. Thank you so much for joining me on this journey through the cosmos today. If you enjoyed this exploration and want to ponder more of the universe's great mysteries, make sure to hit that like button and subscribe to the channel. Let me know your favorite Fermi Paradox solution in the comments below. Stay curious and keep looking up.